So we are going to start off reviewing every factoring problem that we have done so far. And so I gave you this blue sheet to kind of write on so that way you remember where it is and it kind of sticks out to you in your notes. So first thing is turn it sideways to where the hole punches are at the top. Okay, because we're going to make a big old flow chart on here, so we want to make sure we got plenty of room. All right, so at the top, you guys can write factoring. Now, if we think about our names of our functions that we have, thinking about their degree, there are three main types that we factored. But what's the first thing we need to do every time we factor? Look for the GCF. So look for that GCF. Before you start any problem, you look to see if it has a GCF. Then we break this into three parts. Our biggest part is our quadratics. How do you know something is a quadratic? It has 2 as the power. Yep, it's going to have x squared as your highest power. Then we talked a little bit about cubics and quartics. So I wouldn't save a whole bunch of room for those because we only have one example of each of those. So cubic, and we know it's cubic because it has x to the third. And the last kind was quartic, and it has x to the fourth. So those are the more specific kinds that we get into. Now, with quadratic, there are 2 different types that we have in quadratic. We have our binomials. What does it mean to be a binomial? And then we have our trinomials, which means we have 3 terms. Within binomial, there's only one type of problem. And those are the difference of squares problems. So let's look at an example of those difference of square problems. I'm going to pull some from our notes and our homework that you guys have done recently, so that way you have some extra examples to look at. So a good difference of square problem could be 4x squared minus 49. And think about the words. Difference means you have to have what? Subtraction. Squares mean you have to have what? Perfect squares. So a good thing to do in your calculator is to go to y equals and type in what? X to the second power, because that'll give you a list of squares to make sure that those are perfect squares. So 4x squared minus 49 factors how? Two x plus 7 and 2x minus 7. So if it is a quadratic, it has power of x squared, and a binomial with 2 terms. You check to see if it's a difference of squares, and if it is, you factor like problem here. 4x squared minus 49 factors to 2x plus 7 and 2x minus 7. Now if it's a trinomial, we actually have 2 types with our trinomial. We have our short trinomials and our long trinomials. What's the difference? And what does long have? So let's do an example of each of those. So a good example of a short trinomial could be x squared plus 3x minus 10. And how do we do our short trinomials? How do we factor that? Good. We do that scrap work to the side. What multiplies to be the last and what adds to be the middle. Very good. So what multiplies to be -10 and adds to be 3? What are those numbers? 5 and -2. Now, with those numbers, what do we do with them? We put them where? You can put them in the middle, but that's a long way. You put them with X inside the parentheses. So if it's the short way, do the shortcut. Just go ahead and put them with X inside those parentheses, and you are done. But that is the long way, plugging them back in for the middle, and you could certainly plug them back in for the middle and use your grouping. You would just need to put X with them. But the short way, if it starts with X squared, find the numbers, put them in the parentheses. All right, let's do a long trinomial, such as 3x squared minus 16x plus 5. If it is a long trinomial, how do we start it? Good. The first times the last. 3x squared times 5 is, and that's going to equal our blank times a blank. And then negative 16x equals blank plus blank. Very good. Negative 15, negative 1. What also needs to go with them? And now we take those and plug them in for the middle. 3x squared minus 15x minus 1x plus 5. And then we do what? Group them. That's right. So we're going to group our first two, group our last two, and look for the GCF. What's the GCF of the first two? 3x. What's the GCF of the last two? -1. Good, because remember that little trick. If the first term is negative, we have to factor out a negative and change the sign. So let's factor out that 3x from the first two terms and a -1 from the second two terms. We're left with, both cases are x minus 5. That's right. So my two parentheses are and there we go. We have our two parentheses. Now, the way that I just solved this, the long way, can be used for the short way. It can also be used for difference of squares. It's just your middle term in difference of squares is going to be 0 because there's no middle term there. It just has a first and a last term. So if you wanted to do difference of squares the long way, you would write this one as 4x squared plus 0x minus 49. And then you would still multiply the first and last term and do all of that stuff, and you would still get the same answer. All right, that's all about quadratics. That's the 3 types that we factored with quadratics. Those are the same 3 types that we did in Math 2, and you guys did in Math 1. So now let's do our new types, which is our cubic. So that one has an x to the 3rd power. So I am going to do this example. Let's do 27x to the 3rd plus 1. Now, these are cubics, but also how many terms do you have? 2. So these are cubic binomials. If they're trinomials, we cannot do them. So if you want to add in that word binomial, you can. So these are cubic binomials that we have to deal with here. All right, now, how do we start a cubic function? We need to write those as powers of 3, right? So 27 can be written as 3 to the 3rd, yep. And 1 could be written as 1 to the 3rd, yep. Good hint on this, if you have a power of 3, is to go to y equals and type in what? X to the 3rd. Notice the binomials are the same. The quadratic binomial, you type in x squared. The cubic binomial, you type in x to the third, and it'll give you that list, and then you can pick out what numbers you need. All right, this is where we do the little wrap, or have our two parentheses. What's going to go in my first parenthesis? 3x plus 1. So we have the first one, the second one. Then in here, it's the first one squared. Good, 9x squared, because we got to square all of it. Then we do the product of the two. So 3x times 1 is 3x. And then we do the last one squared. Well, 1 squared is 1. The first sign's the same. The second one's not. The last one's always positive. And that's what you got. Yo. So the first one, the second one, the first one squared, the product of the two, and the last one squared. The first sign's the same, the second one's not. The last one's always positive, and that's what you got. Yo. All right, now we're going to do our quartics. And our quartics with x to the 4, the only ones that we worked with in factoring is trinomials. So you guys might remember how to do these. Let's do this one. X to the 4th minus 2x squared minus 8. How do we do our quartic trinomials? Start like a short trinomial, then look for difference of squares. That's it. Okay, short trinomial. We have to figure out what multiplies to be the last, what adds to be the middle. -4, +2 will work. Now, if we start them like a short trinomial, we go straight back to the parentheses, but instead of just x, we have to put x squared minus 4 and x squared plus 2. So, do it just like the short trinomials, just put an x squared. And then, like Tori told us, look for difference of squares. Is x squared minus 4 a difference of squares? Yes, so it can factor to what? Or just x now. Yeah, x plus 2 and x minus 2. X times x makes x squared. 2 times 2 makes 4. Can I factor x squared plus 2 some more? Nope. First off, it's not a difference, and it's not a perfect square. So it's got to be both to go even further. Now, you guys have a quiz coming up when? Tomorrow. So on that quiz, all of these different types, including the GCF, are all going to be mixed up together. And we're getting ready to play Matho, and all these types are going to be mixed up together. But I'm going to let you have your notes out while you play Matho. But tomorrow, are you going to have your notes? No. Now, most of this stuff written on this board is nothing new that you've done before. Everything on the quiz, besides the cubic and the quartic, which you've done the quartic before, it's just a combo. Really, it's the cubic that's new. Everything else you've done in Math 1 and Math 2, right? Okay. So keep that in mind as you go through. All right. So we are going to play Matho. So I need everybody to grab either a colored pencil or a marker or a pen and then a pencil. So you need something colorful and then you need something not colorful. Those of you watching the video at home, I'm going to pause this while we play Matho and I'll pull it back up for the rest of the notes. Okay, due to the internet being down, I can't get to my original notes, so I'm going to make these up on the fly, so hopefully they will work out. So today we're just going to do a few examples on factoring completely. So here is our first example. 4x squared plus 10x plus 6. Now, what do we need to do first? GCF. Start with that first. So tonight's homework, that's really what I want you to focus on. So you've got 12 problems tonight, and the first step is always get that GCF out of the way. So what's our GCF of this problem? 2. Let's take that 2 out, and what are we left with? Plus 5x plus 3. That's right. Now, once you have taken that GCF out, look what's inside your parenthesis. Is it quadratic, cubic, or quartic? It's quadratic because it has a power of 2. Is it binomial or trinomial? Trinomial. Is it short or long? It's long. Those are the questions that you need to ask yourself as you go through this. What kind of problem do you have? We have a quadratic trinomial. It's the long type. How do we do the long type? Good. Multiply the first and the last. So we're multiplying 2x squared and 3, which gives us 6. So we're figuring out what multiplies to be 6 and what adds to be 5, that middle term. 3 and 2 is going to work for us. So 3x and 2x will work. And what do we do with those numbers? Plug them in for the middle. Now, that GCF, so you don't lose it, you can either put parentheses and put that 2, or if you wanted to draw an arrow down to where your answer is, because your answer is going to be 2 parentheses side by side, right, if it's a long trinomial, and that 2 from the beginning is going to go there in the front. So you can automatically pull it down, save some room, or you can keep writing it with each step that you do. Now we use our grouping. What's the GCF of the first 2 terms? X. What's the GCF of the second 2 terms? 1. Now let's factor out X and factor out 1. So if I take X out of the first 2 terms, I'm left with, and the next 2 terms I'm taking out 1, which means I'm not really changing it, so I'm left with what's going to go in my first parenthesis, what goes in my second, and don't forget to bring down that 2 from the beginning. Some of you might can skip this third step right here, this line right here. If you take out those GCFs, then you know that they go in the first parenthesis. When you divide them out, you know that goes in the second parenthesis. So just double check and make sure that second parenthesis works. Okay, let's do this one. Let's do 5x squared minus 5. Now, what's the first thing? GCF. What's our GCF? 5. Let's take a 5 out. What am I left with? Good. Now, inside that parenthesis, what type is it? Name it. It's a quadratic binomial. Quadratic binomials have to be what? Difference of squares. Is that a difference of squares? Yes, it is. So our 5 stays. Difference of squares is 2 parentheses side by side. What's going to go in those 2 parentheses? Good. X plus 1, x minus 1. So that's your habit that you need to get into. Take out the GCF, then figure out what's left. What type of problem is it, and what do I need to do? Okay, let me see if I can find us one more to do. Let's do this one. Where is it? So first I need to do what? Just kidding. Funny, Aiden. Good joke. Yep, take out the GCF. What's our GCF? 3. I like how you're like, no. Don't listen to me. That was funny. All right, then we are left with x squared plus 16. Okay, now what's left in that parenthesis? It's a short trinomial. It's a quadratic trinomial, which means it's the short way. So the short way, good. What multiplies to be the last adds to be the middle. 8 and 2. Look at y'all. I already got this. And again, the scrap work to the side, you don't have to show. Keep that GCF at the beginning. Keep that 3, and then I'm left with x plus 8, x plus 2. Very good. Now, some of the problems that you have tonight are not written in standard form. So you need to get them in standard form. What does it mean to write things in standard form? Highest power to lowest power. Okay, so on the 12 problems that you have on Canvas, write them in standard form, factor out the GCF, and then factor some more. All right? Now, tomorrow we have a what? A quiz. So all the stuff that we just did on that blue sheet and this factoring completely will be on your quiz. Remember, all the problems are going to be all mixed up. So you need to identify what type it is, but always look for the GCF first. And remember, there are some problems, once you take the GCF out, you can't do anymore. Like if you think about the problem that was on your notes or on your homework last night, this problem, I think it was one of the first ones, you can take out a 3 and you're left with a squared plus 3. It's a quadratic binomial, but is it a difference of squares? No. So we just stop here. If there's something more that we can factor here, we go further. But you don't always have to go further. Tonight's homework will, but not the problems on quiz. Yes, on the quiz also will be the stuff that we did on Tuesday, the polynomial operations. So you have to name them by their degree and number of terms. You got to add, subtract, and multiply. So take 5 minutes to look through those notes on Tuesday as well. Okay? Because if not, you might mess up something, especially on the multiply or the subtract. And make sure you know the names, know how to spell them. I won't count off if you spell them wrong, but if you spell them really wrong and it doesn't even pronounce the same way, then I'll count it wrong, okay? So make sure you spell it close. Oh, I had somebody write quad Arctic, and I was like, quad Arctic.